Hello grade 12s, my name is Natasha Barton and I would like to welcome you to question number 3 of the November 2021 Physical Science Paper 2 exam. This question deals with the physical properties of organic compounds, and this is the second question on organic chemistry. This question says the melting points and boiling points of 4 straight chain alkanes are shown in the table below. Straight chain alkanes mean that they do not contain any branches, so they are actually very simple compounds. We see pentane, hexane, heptane, and octane. Already we know pent is for 5, hex is for 6, hept is for 7, and oct is for 8 carbons in the longest continuous chain. We have the melting points. We see that the melting points are increasing as we go from the top towards the bottom. And I say that it is increasing because negative 130 is a smaller number than negative 57. This is a bit confusing to understand because of those negative signs, but again, negative 130 is a colder temperature than negative 57. Then we have the boiling points, and we can see as well that the boiling points are increasing as we go down this column because 125 is a lot bigger than 36,1. Question 3.1 now says, define the term melting point. You learned about melting point in grade 10 already, grade 12s. So you should be able to define this term very easily. We say that melting point is the temperature at which solid and liquid phases are in equilibrium. And for writing this down with the underlined bits, you're going to get 2 marks. Question 3.2 says, write down the general conclusion that can be made about the melting points of straight chain alkanes. When we write down a scientific conclusion, then we are telling the person, the marker, the relationship between independent and dependent variables. Specifically here, the dependent and independent variable in this investigation. We are looking at the melting points, right? So not the boiling points. This is the dependent variable. Something is changing, and as a result, we have different melting points. What is it that is changing? Well, it is the length of the organic compounds. We're going from pentane, which contains 5 carbon atoms, to octane that contains 8 carbon atoms. So to answer this question, we say, as the chain length increases, the melting points increase, right? So as we go from 5 to 8, we see that we go from negative 130 to negative 57. In other words, the melting points increase. Instead of saying the chain length, you could have opted for as the number of carbon atoms increases, as the molecular mass increases, as the surface area increases, or as the strength of the intermolecular forces increases. Any of these would have been accepted. Or you could have stated this the other way around and said, as the chain length decreases, the melting points decrease. What is very important here is that you do not use the term directly proportional. See, these variables are not directly proportional. If some relationship is directly proportional, we are referring to a straight line graph that passes through the origin. Okay, again, direct proportion refers to a straight line graph that passes through the origin, and that is not what we're dealing with here. That is why we only say as the one increases, the other increases, or we say as the one decreases, the other decreases. Please do not use the term they are directly proportional unnecessarily. So this over here is going to get you 2 marks. Question 3.3 says, name the type of van der Waals forces between molecules of octane. Octane is an alkane, and alkanes are nonpolar. There are three types of van der Waals forces that we deal with in grade 12. There are London forces, also known as induced dipole forces. We have dipole-dipole forces and hydrogen bonds. Dipole-dipole forces exist between polar molecules, and hydrogen bonds exist between polar molecules that contain hydrogen bonded to nitrogen, oxygen, or fluorine. Since octane is non-polar, the strongest type of van der Waals forces that octane, the compound, contains is London forces. And for writing this down, you will obtain 1 mark. What is incredibly important to remember in this section is that intermolecular forces exist between molecules, while bonds exist inside of molecules. We break bonds, but we weaken or strengthen intermolecular forces. We break or form bonds, of course. Question 3.4 now says, write down the predominant phase of the following alkanes at negative 100 degrees Celsius. Choose from gas, liquid, or solid. I like to make use of a number line on which I include the melting point and boiling point of the substance in order to answer questions like this. We know that if we have a temperature lower than the melting point, then the substance will be in the solid phase. If the temperature is between the melting and boiling point, then the substance is in the liquid phase. And if the temperature is higher than the boiling point, then the compound is in the gaseous phase. So the temperature given to us is negative 100 degrees Celsius. Negative 100 is between the melting and boiling point. Therefore, the substance is in the liquid phase. And for 1 mark, we write down the word liquid. In question 3.4.2, we're dealing with octane. So octane's melting point is 57, negative 57, while its boiling point is 125. Negative 100 is a smaller number than negative 57. So because of that, we know that octane is in the solid phase. And for 1 mark, we write down the word solid. Question 3.5 says, hexane is now compared to 2,2-dimethylbutane. Is the molecular mass of hexane greater than, less than, or equal to that of 2,2-dimethylbutane? Give a reason for your answer. I would start off by drawing out the structural formulae of compounds like these. I will obtain the molecular formulae and then compare the types of atoms and number of atoms to come to a conclusion. When we draw out the structural formulae and compare the molecular formulae, we find that the molecular formulae are exactly the same. They both contain the same number of carbon atoms and the same number of hydrogen atoms. The correct answer to question 3.5.1 is therefore equal to, so we write down the words equal to, and we need to give a reason as well. As a reason, we can say that they have the same molecular formula, or we can say they're isomers, or we can say they have the same number and types of atoms, or we can say they have the same number of carbon and hydrogen atoms. You're going to obtain 1 mark for writing down the word equal to, and 1 mark for writing down one of the options as a reason. Question 3.5.2 says, is the boiling point of 2,2-dimethylbutane higher than, lower than, or equal to that of hexane? When we compare their structural formulae, we can clearly see that hexane is a longer molecule having a larger surface area, where the other molecule has a smaller surface area because it is branched. We therefore can come to the conclusion that 2,2-dimethylbutane has a lower boiling point than hexane. The reason for this needs to be explained in question 3.5.3, and you had options. I'm going to use the second option, but of course you can read and make sure to understand the first. The section option explains in terms of hexane. We say hexane has a longer chain length, or you can say it is unbranched, less compact, less spherical, or that it has a larger surface area. I would have probably mentioned that it has a larger surface area over which intermolecular forces can act. Then we need to state that it therefore contains stronger, or we can say more, intermolecular forces than 2,2-dimethylbutane, and it therefore requires more energy in order to overcome the intermolecular forces between its molecules. So we need to explain the difference in structure, the difference in intermolecular forces, and we need to mention the energy needed to overcome intermolecular forces. For this, for each one of these points, you're going to get 1 mark, making question 3.5.3 out of 3 marks, while 3.5.2 was out of 1 mark. This brings us to the end of question 3, which was out of 13 marks in total. In the next video, we're going to be taking a look at question number 4, which is still on organic chemistry, but in that question, we're going to be dealing with reactions in organic chemistry.